This is Algebra 2 with Trig, 9.3, talking about independent events. First, we're going to do factoring questions. So notice what's different about this question. We have x to the fourth power. A lot of people get confused with x to the fourth power. And I'll ask them if they understand how to do the problem x squared plus 4x minus 32. And sometimes they're more comfortable working with this problem than they are with that problem. But it's really the same one. This is just factoring, multiplying two things together that make x squared, multiplying two things together that make 32. And when you do the outer and inner, they have to add up to 4. So it would be a positive 8 and a negative 4. So you can be confident with this quadratic factoring. But what about to the fourth power? As long as this is a 4 and this is a 2, that's half the amount. Or 6 and 3. Or 10 and 5. As long as it's half, 2 and 1. As long as it's half, we're going to treat it like a quadratic. We're going to use our parentheses. Leading coefficient is 1. So I can use x squared times x squared, because that multiplies together to make x to the fourth. When you multiply x's together, you add the exponents. To get 32, I can use 2 times 16. I can use 8 times 4. Lots of different choices. But I'm going to need to use 8 and 4 because for me to add to be 8, my outer and inner have to add to be that middle value. It's got to be a negative 4 and a positive 8. That's a method of guess and check. Now notice, you may not get full credit if you have x squared minus 4 left as one of your answers, one of your factors. You have to factor this completely. So you need to realize that this is the difference of two squares again. You can take the square root of the first term, you can take the square root of the second term, and rewrite it with a plus or minus 2. This multiplies to equal x squared minus 4. And this is that value. This cannot be factored. So there we factored it. Factored it completely. Now we're going to come down here and look at this one. Notice that this only has 2 terms, so it's different. Again, this is going to be the difference of 2 squares. X squared and x squared makes x to the fourth. 4 times 4 makes 16. And if you have nothing in the middle, no middle value, then this has to be a positive and negative value. And you might notice that this is also the difference of 2 squares. So x squared plus 4, x minus 2, x plus 2. Because the difference of 2 squares, you're looking for the outside, or the x and x to make x squared. Positive 2, negative 2 makes 0 in the middle, and 2 and 2 makes 4. This one, x squared plus 4, cannot be factored. Common mistake, whereas people call this x plus 2, x plus 2. That won't work. That'll make x squared plus 4x plus 2. Now we're going to slide into the independent lesson. Independent events. So that's our factoring. Now we have independent events. Independent events have the occurrence that no effect of one is affecting the other. It's like flipping a coin. You flip a coin And that does not change the probability of you flipping the next coin. Or you rolling the dice doesn't affect the next roll of the dice. So we have some calculations that we can use if we recognize we're working with independent events. The probability that A happens and B is going to happen. You want two things to happen, two events to occur. That's going to be the probability of A times the probability of B. Don't get this confused with our disjoint and overlapping. That has and also. Okay? But here we're calculating independent events, and we multiply, we do the product of those two probabilities. So, as a lesson, that's the lesson. We've done all the lesson teaching. But here are the practice problems. It's only going to be beneficial if you take time to read the question. You've got to decide on your own, how might you handle this? So I'd encourage you at home to pause the video, read through this first question, and then turn it back on and I'll talk you through it. So here, for a fundraiser, a class sells 150 raffle tickets, gift certificates for a mall. You're selling 200 raffle tickets for the booklets for movie passes. You're going to buy 5 raffle tickets for each prize. What's the probability that you win both? So you want the probability of A and the probability of B. You want both of them to occur. So we have learned that that's going to be the probability of A times the probability of B. So you have 5 favorable tickets out of the 150 tickets. That's your chance of winning the mall gift certificate. And you have 5 out of 200 tickets of winning the movie passes. Those are the probability of you winning. Now we could simplify this, and we see that this is 1 out of 30. 5 goes into 15 3 times, and then you have the 0, and 5 goes into 20 4 times, and then the 0, so it goes into 240 times. And you can calculate this out without a calculator. 3 times 4 is 12, and 0, 0. When you multiply, put those at the end. So you have a 1 out of 1,200 chance. So you can see that winning one of the awards, one of the raffles, is much easier than actually trying to win both. Let's take a step back. There's something I like to show you with this product. Let's talk about true and false questions. We're going to have 2 true and false questions. What's the probability of getting the first question right? 1 out of 2 is the probability of getting one of the questions right? 50%. What's the probability of getting the second question right? 1 out of 2. So a lot of people look at this and they say, well, true and false is pretty good because there's a 1 out of 2 chance to get it right. All right? Well, let's look at the answer key that would be true with true and false. They could both be true. The second one might be false. Perhaps the first one was false, or they were both false. If these were the answer keys, possible answer keys, how many of these would be the correct answer key?
1.
Just one of them, perhaps this one, would be the correct answer key. out of the 4. So to figure out the probability that you get both questions correct isn't 50%. It's 1 out of 4 possible answer keys. 4 different ways that you could answer the questions. 1 out of 4. And we got that from saying the probability of the first question correct times the probability of the second question correct is 1 out of 4. 1 times 1 is 1. 2 times 2 is 4. And we can demonstrate that by looking at the 1 out of 4 possibilities. Even though the probability of each individual question is higher, the probability of guessing, not having any idea what the answer is, guessing your answers, the probability would be 1/4. And that's essentially the same idea we did here. We multiplied the probability of A and the probability of B to get 1 over 1200. Let's look at this spinner. If you have a spinner and we have 10 sections on it, means we're going to have 5 sections on one side and 5 sections on another. So if I extend this bar out there, extend this bar down there, I made 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not that you actually need a spinner, but there would be your possible spinner. So what we're looking for is to spin the spinner, and we're trying to get a perfect square 3 consecutive times in a row. So the first thing you need to realize is, what is a perfect square? So a perfect square, you could say, is a number you can take the square root of, or a number that is created by multiplying a value to itself twice, or to itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Those are your perfect squares that land within the top 10. A lot of people miss 1. You can take the square root of 1, so that's considered a perfect square. Comes out to be an integer. So there is 3 numbers out of the 10 that is a perfect square. That's the probability of landing on a perfect square. And you're going to do that every time. So that's 27 out of 1,000. That would be your probability of landing on a perfect square with 3 consecutive spins in a row. So here's maybe the toughest one. So go ahead, pause the video, take a read of this one. What plans do you need to come up with for this? How would you handle it? We're going to use a method we used yesterday called complements, which may be your friend here. Pause the video. So we're going to look at each day, each of the 5 days of Secretary Week. A secretary is randomly given 1 of 10 prizes. So she gets to do the spinner. She's going to land on a prize. All the prizes are available each day. That's important. That makes it independent. So each day, your probability is not changing. And one of the prizes is a super special prize. Whatever you want it to be, we'll call this a $500 gift card. What's the probability that the secretary receives the $500 gift prize every day? Or, sorry, not every day, but at least once. So that means you win it once, or you win it twice, or you win it 3 times or 4 times, or even if you won it all 5 times. You'd have to do 5 different calculations to handle at least once. So your big key here, what I look for when I read through the question, I see at least once, and I start to understand the direction that I need to go with this problem. It doesn't have or, it doesn't have and, it doesn't have that type of probability of disjoint and overlapping. It has this word at least. So instead of winning it at least once, what's kind of the exact opposite of that? Probability to never win. If that's to win it at least once, the complement of that is to never win. How could you never win the $500 prize? What would have to happen on Monday? What's the probability you don't win it on Monday? There's 9 prizes out of 10 on Monday. And how many days in a row did you have 9 out of 10 choices that weren't the 500?
5.
There are 5 of them. So you could write it out 5 times, or you could use the shortcut of to the 5th power. Your choice of however you want to write that. So with our calculator, we can say 9 out of 10, or 0.9, to the 5th power, or you can type it in 5 times, whatever. There is a 59% chance, but we use the decimal, and I'm going to write all the digits because that is all the digits. If I started to round, I was just going to drop 1 or 2 numbers, so I won't round it all. I'll just write them all down. That's the exact answer. So that's the probability that the secretary will never win the super prize. So how can we figure out the probability of not never winning? So maybe you won it once or twice or 3 times or 4 times or 5 times. What's the other option? So we're going to do the probability win at least once is going to be 1 minus the probability of 59049. It's the complement of never winning it. That would be the probability of winning it at least once. You don't know how many times you're winning it, but that would be your probability. And I wrote down all the digits just because if I was to round to 4, I'm just losing 1. So I might as well write down 5. That's why I wrote down 5. So that's probably the toughest type, and you see the math's not that hard. But you need to understand what you're looking at. Okay, on the flip side, we're looking at some card questions. This has 2 parts to it. This has the part first, you need to understand that we are replacing the card back into the deck. So you're going to receive 1 card. Then you're going to put it back in the deck. Then you're going to receive a 2nd card and put it back in the deck. Replace it and receive a 3rd card. And you want to calculate the probability. Now, this probability, just so we're all on the same page, is a probability of drawing an ace, then a 7, then a face card. In that order. Not just an ace in 3 cards, a 7 in 3 cards, and a face card in 3. That would be a different calculation. But this has to be in that order. So there are 4 aces. There are 4 sevens. And there are 12 face cards. We've talked about all those different possibilities before. So we can reduce these. We know that this is 1 out of 13 times 1 out of 13 times 1 out of 4. If you like to break it down, simplify it down, or you can just use your calculator. 13 times 13 times 4. Yeah, 1 out of 13. Just being sure it's not the answer I was expecting. 1 out of 676. Here, we can do it the longer way. I'll show you. We have 4 out of 52, 4 out of 52, on 12 out of 52. You're going to get a crazy decimal. And we can simplify that fraction. Oh, I'm sorry. It's not 1/4, is it? Sorry, nobody said anything. 6 and 26, 3 and 13. So, I'm sorry, 3 and 13. That's why my numbers weren't making sense. So 13 to the third power, that's my 2191. That's what happens when you try to simplify in your head while you're on video. We have 12 face cards out of 52. I noticed that I botched this one up a lot, but anyway, this is a 3. 1 times 1 times 3 is 3. Okay, let's try it again. What's the probability of a red 2? There's 2 red 2s, 2 of diamonds, 2 of hearts. Then you're going to pick another red 2 after you replace it. Then you're going to pick a black 2. One out of 26, 1 out of 26, 1 out of 26. The calculator would be handy for that. So this is 1 out of 17,576. And then a heart, there's 13 hearts. A red queen, there's 2 red queens. And a 3, there's 4 3s. This is 1 out of 4. This is 1 out of 26. This is 1 out of 13. Again, 1 times 1 times 1 is 1. 4 times 26 times 13. There would be your probabilities. Good job. Again, remember that this is the probability of drawing a heart, then a red queen, then a 3. Not a 3, a red queen, and a heart in any order. It has to be this order.